So there won't be snow in Africa this Christmas time. Is that right? Well, this image must be photoshopped then, because this is Kilimanjaro, and you can see from that yellow dot there that Kilimanjaro is very close to the equator, beside those giraffes. There's no way this is true. It must be photoshopped. Or is it? Well, let's find out a little bit of something more about Kilimanjaro. First of all, it's a mountain that's actually a volcano. It's a composite volcano. It's dormant at the moment. It's not erupting, but it could potentially do so in the future. But it is only 320 kilometers from the equator, and it's hotter at the equator and colder at the poles. So how is there snow in Africa on the top of Kilimanjaro? It's nearly 6 kilometers above sea level. As a result, then you're going to get some glaciers and snow on the top of it, not surprisingly. Of course, Kilimanjaro is the tallest mountain in Africa, and people very often will hike up there for that very reason. This is one American woman who made it up to the top in 2018, took a photograph there, and you can see the snow behind, and indeed the glacier. You see the layers in the glacier? You see the deposits of the ice over different years, almost like a sedimentary rock, and you've got those up at the top. There's the plains way down below. You're above the clouds here. We want to take a wee look at a satellite image of Kilimanjaro here to show the relationship between the height. This is looking at from above. Here's the top of it here. Come down into the lowland either side. And you can see here as you go further on up, you're getting different types of vegetation and land cover, aren't you? With the snow at the top. There's the land use as you come up towards the top. You can see here the snow and this kind of alpine desert area because of the different conditions there. Now this is a true colour image. This is taking the image the way the eye would see, but satellites can look at a much broader range of light than we can see with our eyes. This is the visible light spectrum. Starting from this side, Richard of York gave battle in vain. But that's only a small portion of the light spectrum. In fact, you can have infrared and ultraviolet and indeed others beyond there. You've probably heard of this before. The satellite can see these infrared satellites or infrared images. If you've ever seen any of those police chase programs where the guy is running around and trying to get away from the police at night and the helicopters above, and they're able to see them because it's using this infrared spectrum of light to see beyond the visible light. Ultraviolet, it can reveal other things as well. Now these are things that are actually there but our eyes can't see them. So if you shine an ultraviolet light on your face, it will reveal just how badly sun damaged your skin has become. I'm not going to spend long on this next image because it's pretty gross. Here we go. Eee. So that's what the ultraviolet light reveals. So basically what these can do is to see things that our eyes can't see. It gives us, if you like, a superpower, not quite x-ray vision, but it allows us to see things better and clearer than we can just with our eyes. So let's come back to this true colour image. What we wanted to see was the difference as you come from the lowland up towards the summit of Kilimanjaro. But if I change this slightly and bring in some of the infrared light to make things stand out a little bit more, what I can do is really push the contrast to make it much clearer, those differences in the land use as we go up. And we can see very clearly here that as we're coming up the top of the mountain towards the top of it, we're getting change. Well, let's go from the top down. Snow and ice at the top, into some of this bare ground, into the forests, into the vegetation. You can see that more clearly. And indeed what we can do with this shortwave infrared is that it makes snow and ice come out as a really bright blue. So can you see how it distinguishes here between the cloud and the snow and ice? It's a bit hard to see where the cloud and snow and ice ends and begins there. Very easy to see it here. So that's how these remote sensed satellite images really help us to see what's actually there better, because they give us this superpower, expanding our vision to see what our eyes normally can't see. And if we combine that with a profile image, a side view, like cutting through a slice of a cake here, you can see as the height increases, the mean or median temperature range decreases. Higher ground is got lower temperature, And if you go up above about 4,800 meters above the plains here, what do you get? You get to a place where the median temperature range is -15 to -5. Those are cold enough temperatures to have glaciers and snow on top, despite the fact that this is only 320 kilometers from the equator. And indeed you can see here that as you come from the very warm temperatures down closer to the sea level, as you move further up, you're getting different types of land-covering vegetation up to that kind of deserty area, that upland alpine desert, before you get to the snow. So you can see how as height increases, these temperatures decrease, and despite songs to the contrary, there will be snow in Africa this Christmas time, and indeed all throughout the year, because it's not just latitude that controls temperature, it's also altitude.